Hello again. If you are watching part 1, welcome back. We're going to go over example 1 of rotations and show how we can apply this in coordinate geometry. So example 1 will kind of set the stage of how we approach all the problems. So it's very important that you pay attention to this and see how we do it. Okay, so if we're looking here at example 1, it's referencing this diagram and it has point V here, and another interesting location is point O, which is actually the origin. Okay, so it says, what is the image of R 180, 0, parentheses V? Now, let's break down again as a reminder what all this means. The notation is half the battle. So this R stands for rotation. So we know we're going to have a rigid transformation. We're going to be rotating, but now we need to know how much. So this is our angle of rotation. So we know we're going to be rotating at 180 degrees. This is our center of rotation. And I like to think of this as the anchor. So it's going to be anchored here as it rotates. And I'll show you what I mean about that once we get to the diagram. And this is our pre-image. So after we're done rotating this, we're only rotating one point, it seems. That's pretty simple. It's going to be equal to V prime. That's going to be our final result. Okay. So 180 degrees, that's half a circle. So if we were actually to draw a circle around here with, and let me change this so we can see what's going on. Okay, let's have no fill. So if we were to have a circle drawn like this, this is a little imprecise. 180 degrees would be around the circle and halfway. So if I were to guess, I would guess in this general area, but I'm just kind of estimating here based on my circle and based on knowing that 180 degrees goes across the center of the circle like that, 180. So, and a way to reference that too is when a skateboarder does a trick, he does a 180. If he has his left shoulder as his leading shoulder and he rotates 180 degrees, his right shoulder will be facing the front now, okay? So I'm going to go ahead and erase this because that's not how we're going to approach this problem. I just wanted you to visualize what a 180 degree rotation looks like with O as its center. Okay, now how I approach every one of these problems is I like to construct like a framework. So I'm going to use green and orange for my framework here. What do I mean by that? Well, if I rotate it, if I connect this to here, it's almost like I'm going to be swinging this line 180 degrees. Now, knowing how far this 180 degree swings, that's the tough part. So, and the reason why it's tough is because it's at a slant. It's at an angle, which really doesn't help us very much. Especially when we're talking about the coordinate plane, where everything's in an up, down, left, and right axis. Okay, so what I like to do is I like to give it an up, down, left, right axis by creating these supports. Let me show you what I mean. So I am going to try to get from my anchor, my center of origin, my center of rotation, and I'm going to create some supports to connect, let me make it orange actually, to connect to my point of rotation. Okay, I'm going to clean this one up just a little bit. I'm not OCD, I swear. All right. So now I have a 90-degree angle, and that's not tremendously important, but what is important is I go horizontal. Sorry, I swear I'm not OCD. I go horizontal and then vertical to get up to my point. The reason why this is important is because now I can see how to rotate this a lot easier. What do I mean by that? Well, let me erase this orange one real quick. If I were to rotate this green line, imagine there's a little end to this green line. If I were to rotate this 180 degrees, where would it land? Well, it's easy to see. It would land over here. Because if I rotate it 180 degrees, it's real easy to see that that's 90 to be a right angle, and then a straight angle would be 180. So it would land over here. We use horizontal and vertical supports because it's easy to see the rotations with 90, 180, and 270 degrees, and also 360 degrees. It's very easy to see because we're very familiar with it going from horizontal to vertical with 90 degrees, and then a straight angle is completely from horizontal to horizontal, and so on, okay? So we're going to think of everything in that light, where we're going to be using this horizontal support to rotate. Now, this connector is going to stay attached to this end piece after we rotate it. Okay, so wherever this connector goes, these two things are going to go. Now, we're asked to rotate it 180 degrees. So we're going to do that. Just how as I showed before, okay, I'm going to draw this again. We're going to rotate this, and we're going to move it 180 degrees over here. Okay, now keep in mind, as I'm rotating it now, you need to visualize, imagine that this orange line is connected to it as it rotates. So I'm going to show you here. I'm not going to maintain the perfect. There's 90 degrees, as we can see with the green. And then there's almost there. There's 180. So as we rotate it 180 degrees, okay, we notice that the orange support automatically moves with it. You need to at least visualize it. So what I like to do is I like to draw two of these. One is before, and the second one is after. So you already saw what the first one looked like before. I'm going to make it dotted. This is the before. So this is the before. Okay, and the only one I'm concerned about rotating is the green one. The green one's important because that's the one that's attached to the center of rotation. The orange one is not attached to the center of rotation, so I just have to draw that after I'm done rotating the one that's attached, which is the green one. Okay, so I rotate the green one 180 degrees, as you can see there, and you should know why that's 180 degrees. It's a straight angle. And now I need to make sure that it's still going in the same direction. Clearly, this wouldn't be pointing up because that would mean that would be posted on the other side. Okay, it's coming out from the, if I were to hold this vertically, it's coming out to the left of the green line. So as I look around this way, it still needs to be to the left of the green line, okay? So I rotate it, and this point V maintains its relation to the end of this. So this is now the location of V prime. Now, before I get into example 2, I want to explain this in one other way. Okay, so let's see if we get to the same spot. And this was about where we thought it was going to be when I showed the big circle to begin with, okay? So we did it that way. Okay, now what if you want to make your support a little different? Let's have the support go vertical first and then horizontal. Can we do that? We sure can, as long as you use only horizontal and vertical lines from the center of rotation to point V, you're fine, okay? But you need to at least use horizontal and vertical lines and then connect the center rotation to the point that you're rotating, okay? So let me get my green line here. Same process. So here's my green line. I'm going to rotate this 180 degrees so that it's going to be pointing from up to down, okay? That's 180 degrees. That would be 90. That's 180, okay? So let me draw this down. How many units is it going down? Sorry, my Apple Pencil's really giving me fits here. It's not appreciating me. Okay, it's going 5 units up. So if it's going 5 units up, if we rotate 180 degrees, it's going to be going 5 units down. Now, my other support that's connecting to it, like it's almost like a beam. So imagine I'm building a beam or a wooden plank connecting to it. It's going 2 to the right of my green support. So if it's going 2 to the right and I rotate it so it's facing down, it's still going to be going to the right, but it's be going this way. Okay, it's going to be going this way. So that's how I know I can do it 2 different ways and I still get the same thing. That is one way to consider rotations. I think it's the easiest because then you can change this center of rotation to anything and you'll still be able to do this problem. Coming up after this video, we're going to do example 2 and example 3.